It was one thing to grasp how two species of finch could become different, how their beak shape could change. That was a small step. But what about the big differences? The differences, say, between the fish that swim in the sea and the animals that walk on land. How did those changes take place?
How could a fish develop legs and walk on land? Darwin had no idea. But Neil Shubin was determined to tackle that problem.
It captured my imagination. I mean, here's a fin, and on the other side was a limb, and they looked different in many ways. And I thought, well, what a first-class scientific problem to devote my research to. And I've been devoting pretty much my research to it ever since, over 20 years.
The first stage in Shubin's quest was to find a fossil. If Darwin were right, somewhere out there had to be a transitional form. A fossil that was part fish, but had the beginning of legs. But where to look? He had one clue. The fossil record shows that creatures with legs first appeared some 365 million years ago. Before that, they were only fish. So summer after summer, Shubin set up camp on Ellesmere Island, just a few hundred miles from the North Pole. It has exposed rock from that crucial transitional time. The scientists' own video shows how remote and bleak the place was. Each expedition was costly, but after 3 of them, there was little to show for their efforts. A 4th trip seemed pointless.
I remember having a conversation with my colleagues, saying, well, should we go? Is this really a waste of money? This was our do or die moment, and we almost didn't go.
But they decided to try one last time. After 3 days, they still hadn't found anything. Then, just when no one was expecting anything to happen,
a colleague was cracking rocks, and I was working about 5 feet from him. And I hear, hey guys, what's this? Sticking out of the cliff was the snout of a fish. And not just any fish, a fish with a flat head. And by seeing a flat-headed fish in rocks about 375 million years old, we knew we had found what we were looking for.
a flat snout with upward staring eyes, the signature of an animal that pushes its head out of the water. And for that, it would have needed something like arms.
What we did at that moment was all jump around, high-fiving. It was there were only 6 of us in the field that time, so it was quite a scene.
Back at home, Shubin and his team got to work, examining their 375-million-year-old fossil. They named their new finding Tiktaalik, an Inuit word for a freshwater fish. Tiktaalik is a perfect transitional form. Much of its body is that of a fish. It's covered in scales. But it also had something very unfish-like. An arm-like fin, or perhaps a fin-like arm. Tiktaalik had the bone structure that is seen in the arms and legs of every 4-limbed animal. One big bone at the top, 2 bones underneath, leading to a cluster of bones in the wrist and ankle.
You now have an animal that can push itself up off the substrate, either on the water bottom or on land.
One obvious question was why had Tiktaalik evolved this new structure? One possible answer is suggested by other fossils found near it.
There are large predatory fish about 10 to 15 feet long living alongside Tiktaalik.
Tiktaalik was prey. To survive, it had few choices.
You can get big, you can get armor, or you can get out of the way.
Shubin thinks Tiktaalik got out of the way. With those arm-like fins, it could have dragged itself to safety on land or in the shallows. But this was only half the answer.
What it doesn't show us is the actual genetic mechanism, the genetic recipe that builds a fin into that which builds a limb.